Welcome to DataBuckets Academy. This is part 2 of Sequence, using the example of exploring a user's journey before they drop off. In the first part, we have created and configured the sequence, so it is focused to only the key events that we want to analyze. To continue this sequence, I can also take a closer look at each of these events, for example, to see the exact timestamp when they were triggered. To do that, I'll go up here to Sequence Event Name, trim it to 20, and then add the timestamp here. I hit Submit and run again. Now I can click on any event to see when exactly it was triggered. For example, this event was triggered on Monday, October 27, 2025, at 1 p.m. 8 minutes 8 seconds and 677 milliseconds. That's accurate down to the millisecond. If I select two events at once, I can also see the duration between them. For example, between Go to Screen and Open App, the user triggered Open App just 243 milliseconds after Go to Screen. So that's what you can do with the timestamp feature here. It helps you understand the exact timing between actions. Moving on, we have many users here, and each user has their own set of events. What I want to do next is to summarize this data, to find out what are the common sequences of behaviors across users. So I'll go back up here, edit the sequence, and turn off the timestamp. When timestamps are on, no two users will ever have the exact same sequence since every timestamp is unique. After that, I'll click Submit. And from here, I'll use the option Select from this step. Now, the Sequence Event Name column is actually a calculated field, so you can't group or count directly from it. That's why we use Select from this step. It allows you to turn both user pseudo ID and sequence event name into fields that you can group by. Once that's done, I usually group by sequence event name first, and then count distinct user pseudo ID to see how many users share that same sequence. Finally, I'll rename that field to number of users. Okay. So now we have this sequence here. This means that there's one user who followed this exact set of events before they dropped. What I want to do next is to find the sets of events that have the most users, which also mean the most common user behaviors before drop-off. Looking at the list, I can already see there are a few events I don't really care about, for example, #score. So I'll go ahead and exclude those from my sequence to keep things more focused. Once that's done, I'll sort the number of users column in descending order, so that the most common sequences appear first. And there we go. Now we can clearly see the most frequent patterns of behavior among users before they drop. So, as you can see here in the results, there are quite a few empty sequences. That usually happens when the configuration isn't fully optimized. There are a few ways I can fix this. For example, I could increase the sequence length, maybe to 1,000 or even 2,000, so that more user events are captured. Another way is to narrow down the user group which you build the sequence on by setting more specific conditions for input users. And the third approach is to adjust the conditions for the start item and end item. Usually, after fine-tuning those settings, you'll end up with far fewer empty sequences. Now, moving on in columns right here, I can add color to the number of users field to make it easier to read. I can also perform a few additional calculations. For instance, I can select from the previous step and calculate the total number of drop-off users by counting distinct user ID. I'll name this new field Total Users. Once I have that, I can add a percentage column by creating a simple formula. Number of users divided by total users times 100. Then I'll name that %. I'll also hide the extra columns to keep things neat. When you scroll down, you can see a list of sequences, each one showing how many users followed that pattern and what percentage they represent. To make it more visual, we can add a Sankey chart. Here, I'll set number of users as the metric and sequence event name as the sequence field. So here's our Sankey diagram. As you can see, there are still quite a few thin lines, but what we really want to focus on are the larger lines, the key paths users usually take. To clean this up, I can filter out sequences with fewer users. For example, only keep those with more than 50 users. Once I run that, the Sankey chart already looks much neater. I can go a step further by removing nodes that aren't meaningful for analysis. For example, events like open app or load. By excluding those, we make the flow much clearer and easier to interpret. And you can repeat these steps as needed until you get a clean, focused sequence visualization that truly reflects the user journey you want to analyze. Okay, so now we've got a pretty interpretable Sankey diagram here, and we can start analyzing it by hovering over the nodes. From here, we can see what users typically do before removing the app by looking at the incoming events. For example, the most common event right before app removal is Notify Request Permission. That means users receive a pop-up asking whether they want to allow notifications, and for many of them, that turns out to be their final event, right before they uninstall the app. The second most common pattern we see is the event in detail, which, in this case, represents when users view the 3D effect of a wallpaper. About 28% of users who uninstall the app had just viewed a 3D wallpaper beforehand, probably meaning they didn't enjoy what they saw, so they decided to remove the app. You can also interpret earlier parts of the Sankey in the same way. For instance, when you look at the event Go to Screen/Home 3D, you can see the incoming nodes, which are the events users triggered before landing on that screen, and the outgoing nodes, which show where users went next. In this example, most of them went on to Notify Request Permission. Now, something interesting here. You'll notice this white segment in the Sankey. This represents users who didn't have any event after Notify Request Permission. That tells us around 10% of users dropped off right at that point. By analyzing the Sankey this way, you can easily identify the most common behavioral sequences before users churn, and also pinpoint exactly where they drop off, which event typically leads to the uninstall. The Sankey visualization is super flexible. You can add as many parameters as you want, explore loops, and the best part is, you don't need to predefine any events. It's a direct reflection of the real sequences users go through in your app. So, that's how you can interpret the Sankey and uncover meaningful user behavior insights. Thanks for watching this video. If you have any questions, feel free to reach out to our support. For more information, please refer to our documents linked in the description.